Hey everyone, good day all. Thanks for joining this session. I think we are good to start. Naveen, what do you say? Yeah. Uh, Thank you all. Just a moment. Okay. So I hope you're able to hear my voice as well. Um, a warm welcome to you all for the today demo session. It's a day 2, uh, and this is the Advanced Machine Learning and Generative AI course. And don't worry if you're new to this demo session, if you haven't attended the previous one and you are joining the current one, don't worry. You are at right place, and I'll just quickly uh, explain everything in simple and beginner friendly way what we have discussed yesterday and that during the demo session 1. Okay. So yesterday we had a huge number of audience who have interested in our course and they have joined, and the course agenda started with the job market and trends. So, what is the current market for machine learning engineers or the LLM engineers or the generative AI engineers? Um, so all this, what is the current job market trend for these trend, and what is the salary structure and the growth for an entry level or mid level engineers? So we have started with that discussion, and how the organizations are reskilling, upskilling their workforce, aligning with the AI architecture into their field. Okay, so that's one thing we have discussed yesterday as a first point. Also, we have discussed the skills required for any ML or generative GenAI engineering. So what we have shown with the Naukri profiles, and we have explained you what the companies are looking into uh, for these machine learning and GenAI engineering as the skills, and what you're going to learn out of this program when we say skills required. So we have detailedly also explained what is the uniqueness of our program. Right, as you mentioned, like the program is designed in such a way that it is um, easy. It starts from the zero to advanced level, and it's a 100 hours live program, as mentioned, and it's an industry curriculum focused. And the experts that are going to be mentors for this program are already well versed with the knowledge on this program. And we are also providing the 3 capstone project, which one is the machine learning project, where we have talked about the healthcare domain, and we have already explained like how we are going to work on the project side. Now also, we have shown the assignments on a weekly side and the lab sessions. We have shown the detailed notes how we are going to provide you on that. So that's the uniqueness about the program we have discussed yesterday. Also, we have discussed the people who are interested in the program who can enroll into the, like IT professionals, the who are looking to switch to AI and ML field, or the non-IT professionals who are looking to transition to this field, or somebody freshers who doesn't have the knowledge but still wanted to enroll and get into high-paying jobs. So we have explained in detail in the day 1, and we have also covered the syllabus that we are going to detailedly explain as part of this course, job-oriented program. So majorly, the program teaches about the basics of these three, like Python, maths, and statistics. We will cover these three as a basics, and we will immediately go through the machine learning models, what is supervised, unsupervised in detail, and with the lab practices as well. And also, we will going to learn about the MLOps and the how you're going to integrate the ML pipelines for the models that you have developed. And also, we will learn about the deep learning, NLP, GenAI, how to deploy those models. So we have discussed yesterday these things. I hope this is clear. Let me talk in detail. Yeah, just a moment. So also, we also mentioned that how the AI field is, and what are the different terminologies that are being part of this course. Okay, artificial intelligence, machine learning, deep learning, and generative AI. What type of what type of fields that you're going to work, and what are the types of roles that you're going to be work with. So these are the roles: machine learning specialist, Gen AI engineering, deep learning engineering, AI specialist, and engineering, LLM engineering. These are the fields you're going to work as a title when you learn and join this course, and when you go into the market, you'll be able to apply to these roles after joining this course. Okay. So just a moment. Let me log in to my beautiful AI presentation. So this is what we have discussed yesterday. Now coming to day two. So day two, we are going to discuss about what is in detail about the machine learning, the definition, how it will be useful, and the types of machine learning and steps with the agenda. And also we will cover the mind map on the this part. Okay. So yeah, just so here is the presentation. Yep. Okay. Navin, just confirm if you're able to view this presentation as well. Okay, so without wasting much time, let's dive into the session. Let's begin with the exciting question. So what is machine learning, right? So to make it simple, um, I just wanted to explain you what is machine learning is nothing but it's about teaching the computers to learn from the data, just like we learn from the examples, right? So let me take one examples. So if I, if I show 100 pictures of cats and dogs, and you repeatedly I show them, you learn to tell them how do you differentiate apart, right? Okay. If you give it a kid that okay, different colors of fruits like oranges and apples, so how do you differentiate? You repeatedly learn that, and oh, this is apple, this is color, so you learn from the experience, and you will try to form an opinion out of that. You don't need to code that. That's what machine learning about. You don't need to explicitly program, and simply make the decisions. So we don't write any rules out of this. So this is the machine learning about. And now I wanted to cover what are the applications of machine learning first, and then wanted to go into the types of learning here. So let's see, let's take the real world examples that we deal day to day. So first thing is Gmail spam. How does the Gmail know that what are the hundreds of mails that you receive a day? How does it differentiate whether it's a social media or mail, or whether it is a content generation mail, or whether it is a mail that only matters to you on the inbox? Okay, whether it's a spam, how do you detect it? Using the machine learning models. This is the one of the application here. Okay. Also, I wanted to show you the recommender system. So these days, when you buy a product from a e-commerce website, it recommends a lot of products to you, right? So how does you get this recommendation? So you haven't served much, but you only shown interest to that, and uh, based on this, the products will be recommended to you. So this is also where the machine learning models will be deployed on your search, and so that the related products will be recommended to you. And also one more application I wanted to show is Google Maps. So earlier in the olden days, probably like when we were a child, if you wanted to reach certain place, let's say 500 kilometers from the current distance, and it takes 8 hours to reach that. That's all. The speed is equal to distance by time. But now with the Google Maps in mind, you will be able to actually predict how much time it takes for you to reach that place. Okay. So considering all the traffic areas or the road work that is going on, or the maybe um, kind of route diversion, these things. So all these things will be on real time basis, and you based on the models, machine learning models, it tries to gain a lot of data, and it tries to train the Google Maps, and then it will learn that it will show that this much time it is going to take. See, this is all. So it's, from flight, it shows different routes, whether you wanted to reach by flight, you wanted to reach by time. How it all happened because of the past data, many number of people that travel, and it took the data, and it is showing the recommendations to you. So this is the machine learning application. Okay, so it's about simply learning. Yeah. So let me go to next slide. The types of learnings. So there are types of machine learning models are available based on the learning approaches. Okay, how does the machine learning? Based on that, we divide the machine learning model into four types. Majorly, one of them is the supervised learning, um, and the unsupervised learning, and the semi-supervised learning, and reinforcement learning. So supervised learning. So what does supervised learning means? You know, it gives examples with some answers, like showing a photo and saying that, oh, this is cat, this is dog, this is something. Like you are able to label uh, to your data. What label data here means is like you're able to characterize your data to specific. Okay, it has some structure, and you're able to making some decisions out of that. Don't worry if you are confusing at this moment. I will explain you when the example comes here. But for the definition purpose, supervised learning is nothing but it learns from the labeled data to make the predictions. That's how you can remember easily, right? And the types of supervised learnings available are linear regression, logistic regression. These are the decision trees. These are all the machine learning models under the supervised learning. Okay, and the next comes the unsupervised learning. So unsupervised learning doesn't need any labeling. Like you don't know whether what's that character. You have the data, but you cannot label it, whether it's a cat, whether it's a dog. You are not able to label it. What you'll have to do is you will you know what you will differentiate, like you will cluster out them in ABC formats, and after clustering out you will differentiate whether it's a cat or not. Okay, that's a simple understanding about the unsupervised learning. So what are the different types of unsupervised learnings are available? Like dimensionality reduction, clustering, anomaly detection. These are all the different models are available under the unsupervised learning. Okay, and then next, semi-supervised learning. Semi-supervised learning is nothing but like you get a few answers. Like you get, it's a combination of both supervised and unsupervised. You get the labeled data, you get the unlabeled data, both. Okay, and you use the combination of these two to improve the model performance. Okay, I'll show you in upcoming slides how it is going to explain. Okay, and then comes the reinforcement learning. Okay, this comes in the interesting part. Reinforcement learning is nothing but it's a trial and error method. Let me give you one example. Let's say, for example, a robot is learning to walk by getting it reward. So if or the self-driving cars. So when somebody uh, a self-driving car learns from the algorithm that has been developed by software, and whenever somebody obstruct that car, what it tries to give is it learns that, oh, somebody is coming, I have to decelerate. So that kind of um, reinforcement learning, that's about the example of the okay. So now we understood that the types of machine learning. Let me take a pause here and example. So machine learning is not very much new to these days. Like it's been there for decades actually. Like somewhere it started in 1950 with the basic neural networks, and in 80s 90s also it evolved with support vector machines and natural language processing. But lately in 2020 it has been evaluation into generative AI. Okay, so yeah, so the advancement of machine learning is nothing but the generative AI here. Okay, so simply in terms of machine learning, advanced machine learning techniques are being deployed, and they act as a generative AI models. Okay, so that's about the history. But let me explain you simply what supervised learning in terms of example. Okay, so here what you can observe with different images of the cat. Um, okay, different images of the cat, whether it's sitting, whether it is viewing at a close, whether it is standing. So these are all the different images of cats are available. Like so, what it gives you is when you give it to the machine, what it will say answer like this is cat, this is cat, this is cat. It all machine learns that by looking at the image, it is able to predict cat. So it's like it's machining training itself that this is cat. Okay, yeah. Um, but how how do next knows that you have given a different images, and machine will learn that from the different images that you give the input based on the training set already. It is able to predict that when you give the cat or elephant or the dog images, it automatically predicts that. So this is about the simple supervised learning. Like, you have the data, you train it and repeatedly, so that when you give the other input some test data, it gives the output as it is easily able to predict. So that's about simply machine learning, supervised machine learning. Okay. So this is all, you are able to label this as a cat, as I principally explained. But how does it differentiate from unsupervised learning? You you don't you don't have the proper structured data. Like, you have lots of data being loaded into the system, and what the system will do, it doesn't have any labels. It doesn't know whether it's a cat, elephant. It doesn't know anything at all, right? So what it will first try to do is, first thing is, it will try to cluster out the based on the training data. Let's say, for example, it tries to cluster out all the similar models, elephant into cats and elephant and dogs, and after that it tries to label. So unsupervised learning deals with the unlabeled data. Okay, so this is how it is being structured here. Like, so unsupervised learning, most of the times in real world, we do see a lot of times unsupervised learning only. Data is very much not going to be structured. Okay, and what you'll try to do is, you will try to formulate some data out as output, and then try to structure out. Oh, once again, you'll have to label that. Okay, this is about the unsupervised learning. Now comes the interesting part, guys. Okay, um, how does the machine learning flow works actually? How it actually works actually in real world? How does a machine learning model learns? So I think if you heard my yesterday class, uh, I already explained this part, but let me recap what exactly. It has 5 simple process steps. Like, you collect the real time data, whatever the relevant project that you want to do. Let's say, for example, I wanted to take a project, do a project on a healthcare domain. What you'll have to do, I'll have to collect the data relevant to that. Okay, whatever, whether it is a from different databases. Say, for example, I wanted to take the data from data in CSV files or any API files, or if it is connected to any DBS or from some kind of service, you collect the data, you keep it with you, and whatever the data that you have is not very structured. That might miss out some missing values, or that might be handling not structured data. Let's say, for example, instead of integers, numbers, you may have the some string or text, which is not going to helpful for you. You'll have to pre-process that. So on a second step, what we will do is, we will pre-process that data. Okay, and then you clean the data. So that machine learning, it will be useful for the machine learning model. Okay, you encode that into some category level, you pre-process that on a second step. Now you're ready with the your data. So what's the next step that you're going to do? Once you clean and prepare the data, what's next step is, you choose the proper model. For my machine learning model, if I wanted to predict whether a patient is diabetic or not, I obviously choose the logistic regression model, because it only gives whether a person diabetic or not. That's what yes or no. That's it. So simply, you will choose the appropriate machine learning model based on the data that you have, or problem that you wanted to solve. Okay, so then after setting that, what you're going to do is, you have 100 rows of data. Let's say, for example, what you're going to do is, you will train that data 70. You'll split that data into 70-30%. Let's say, for example, 100 rows of data, you have 100 rows, and let me write it here simply. um, you have 100 rows of data, and now what you'll have to do is, you will have to split the data, split it into 70 percentage data for the training. You'll have to, just like previously how we trained the cat, like repeatedly, this is cat, this is cat, this is cat, right? Similarly, you'll have to train that 70% of the data. Then rest of the 30% of the data, you're going to test it on whatever the 70% data you have, right? you will have to take that 70% of the data, so that you will try to find out what patterns it is going to show. Okay. So similarly, what you do, based on the output, evaluate whether that 30% of the model evaluation will show how much accuracy of the model. Let's say, for example, after you evaluate, you got 70% of the accuracy of the model. Now, what you're going to do is you will have to, once again, if you feel satisfied with the accuracy, then you go and deploy that model. Simply, that's it. Okay. Yeah. So this is about the machine learning flow. So let me recap once again. What's the machine learning flow? You collect the data, you clean it and pre-process it, and you select the appropriate model, and then you split the data into 70-30 ratio, so that your model data can be trained and evaluated. And once you know the output of the accuracy, you try to deploy that model. This is the simply workflow. Okay. So this is the machine mind map that we have created. So for the supervised learning, what are the types of supervised learning models are available for you? Like for under supervised learning, we have majorly two categorical sections are available. Like one of them is regression and classification. So regression is nothing but tries to predict a real number. Classification is nothing but it tries to differentiate into one different classes like A, B, C from the data. So under regression as well, we have couple of regression models available: linear regression, polynomial, ridge, and lasso. Don't worry about these things because when you actually come into the classes, these are quite easy. Linear regression is nothing but y is equal to mx plus c. In your childhood days, you would have seen, right? Simply that, like you will whatever the data you have, you tries to align with that line y is equal to mx plus c, and you predict the output. That's it, simple. So similar to regression, we have other models in the classification as well, like logistic regression, where instead of representing in a linear regression form, you tries to differentiate the same line in logarithmic form. That's nothing but logistic regression. So don't get panic, because these are all only the mathematical equation that you're going to train it. So when you go into the class, what I'll do is like I'll start with the theory class for each and every topic, and then immediately I'll go into the lab how you're going to practice it with the Google Colab that I'm going to mention here. So let me take one example here. I'm not going to detailedly go into this. This is one of the tools that we majorly use to write, programming. You can also use the Jupyter program. What you simply run is like you import the libraries, you load the data here. Whatever so far the process we have explained, right? Load the, prepare the data, clean it, and choose the model and train it. So all the steps are performed here simply in this. So this is the data I'm loading it for my model. What I'm going to do is I'm going to use so just a minute, yeah. So I'm going to use the linear regression model here simply, so that my data can be trained and once again tested, so that I'll get the accuracy of the model. 85% of the model it is accurate. So simple. This is how, like, for every different machine learning model, you'll follow the same steps. Okay. So yeah, now I think we learned about the supervised learning. So unsupervised learning also same way. It has two different classification once again: clustering and association. So clustering is nothing but like whatever the data that you have, you try to clustering into ABC formats, and based on that, once again you try to predict the accuracy of that model. Okay. So this is about classification. Different classification models are available, like k-means clustering, hierarchy, DB-scan. When you see these at the beginning, you might see panic, but when you actually practice, those are quite easy. Okay. So yeah. And ensemble learning is nothing but the how to improve the accuracy of the model. Let's say, for example, you have the data and you predicted some output, 90% of the accuracy. Now you are not satisfied with that data, you wanted to improve that 90 to 99%. For that, there are some techniques available, bagging and boosting, where you will use these techniques to improve the model accuracy. Okay. So this is about yeah. Yeah, there are so far what we learned is based on the um, learning approaches only, but we have other type of models. Same thing being classified into different sets. Let's example, earlier we learned about the learning based approaches. Now we are learning based on the modeling approaches. Okay, so there are two types of available. One of them is the discriminative and generative. So let me go to next slide. It is explained here. So discriminative model is nothing but you have the random data. You are able to classify it into differentiate using some lines or something that okay, this is you're discriminating the models based on the decision tree model. Let's say for example like logistic regression neural network, all these models are discriminative models. Whereas generative models is nothing but whatever these days that you see on a Claude or the Gemini or the OpenAI, Gemini, ChatGPT. These are all the advancements of machine learning models, generative AI models. It learns from the input, whatever the data that you get to, it tries to cluster out based on the input that you have. It tries to generate the new data. It tries to generate the new data. So these are all the new techniques that you learn as part of the generative models like Navis Bay, Gaussian, these are all. Okay. So this is about the generative AI models, guys. So far the learning is for this only, but I just wanted to take a quick pause here and ask, get some questions from you if you have anything. Or if you have any questions, you can ask in the group chat as well. So that we'll try to answer anything about the machine learning. Okay. So yeah, this is about the machine learning program that I'm going to cover in detail when you come to the class. It will be much detailed in a simpler way. Just like theory part will be probably 10 to 15 minutes of the class, but rest of the class will be lab sessions. In detail, I'll explain you how to go because when you go on and work as a machine learning is you are going to do this job. Okay, so this is what I'm going to offer you guys. So yeah, that's all about the machine learning demo for today. So I would just wanted to take a pause here and invite my co-instructor Naveen to explain what is deep learning about. Okay. So Naveen, can you please take it from here? So I'm just stop sharing my screen. You can take it from here. Niyaman. Yes. Just a moment. Maybe you can proceed, Naveen.
Okay, yeah, let us start deep learning. So it won't take much time. Okay, so we have decided to keep this session very light. Okay, just giving you the introduction of the fields of artificial intelligence. Yes, this we have already discussed yesterday and today as well. This is the AI ecosystem. Okay, I'm not going to go deep into that, but deep learning is a subfield of artificial intelligence, just like machine learning. Okay, and here you can see a person named Geoffrey Everest Hinton. Okay, so he's called as the godfather of artificial intelligence, you know. And if artificial intelligence has taken,
Naveen,
strong
it's
leaps
echoing.
or strides, right? He is one of the major contributors to it. Okay, and he was awarded Nobel Prize as well recently. Okay, yeah, I'll tell you what contributions he has made to the artificial intelligence shortly. Okay, yeah, firstly, when we talk about deep learning, we must know how this was evolved or how this was introduced. Okay, so it all started in 1940s, the basic idea. So that's the reason I kept a brain inspired idea. Okay, so these two scientists have got an idea: how can we make a machine think like a human brain? Okay, how can we make a machine think like a human brain? And also, how can we make a machine learn exactly like a human brain? Okay, so they just wanted to introduce this concept to the world. Okay, so at that point of time, this was a sparkling idea because nobody thought about it. How can we make a robot which can think exactly like a human, right? So it all started in 1940s. However, um, uh, major contributors were there after that. Okay, so this is the point I was saying, and all these six timelines I have kept over here, or significant impacts created in the domain of artificial intelligence. Okay, so it all started in 1943, and this is what we'll have to concentrate more. Okay, in in 2016, you see, I was saying, right, they have created a machine which can think like a human. So in 2016 it has developed a lot and evolved a lot. Okay, that particular algorithm. Okay, and this AlphaGo is one type of such model or algorithm which was developed by DeepMind, a subsidiary of Google. Okay, so the Google company has introduced this algorithm. You know what it has done? It defeated the world champion in the game of Go. If you do not know what this game of Go, it is just like the chess game. Okay, chess game will have millions of probabilities, or like permutations and combinations, right? This game of Go will have higher permutations and combinations for playing entirely till the checkmate. Okay, but this particular algorithm has defeated the world champion in the game of Go. This shocked the world at that in this year. Maybe you would have also heard about it in newspapers. So this is the biggest achievement for the machine, right? Defeating a human, that to a world champion. So that's what a neural network can do. Okay, yeah, firstly, when I say deep learning is one of the subfields of artificial intelligence, you must have got the doubt what it can do, right? So here I just kept small definitions or the features of deep learning, but you will come to greater understanding in the next slides. Okay, so I'm skipping this slide for now. So the actual definition comes up here. So deep learning is a subset of machine learning and artificial intelligence that you already know, which uses multi-layered neural networks to model and understand complex patterns in large datasets. I know this is a little bit confusing, so just leave this apart now for now. Okay, deep learning is inspired by the structure and functioning of the human brain that we have discussed, right? But Firstly, we'll have to know how human brain works inside, right? So human brain is a biological organ for all of the human beings. What it does is, this is a simple nerve cell. Each of the human brain contains billions of neurons or billions of nerve cells. Okay, this is a particular a single nerve cell. Okay, we'll understand what is happening actually inside. So today is April uh, 24th, right? So today I'm giving a second demo on deep learning, right? So when I wanted to give a demo, or if I wanted to talk with someone, my brain is already taking some inputs from some other nerve cells and processing it, and then sending it to this other nerve cells, right? So some processing is happening inside my brain, which is making me to talk fluently or talk to you in a very understandable manner, right? So let us see the three main parts of a human brain nerve cell is dendrites and cell body and synaptic terminals. Okay, so dendrites, they take the input. Okay, whatever the input may be, input may be understanding of new language. Hope you can hear my voice clearly. I see someone saying that there is a echo. So can
Now it's
someone
clear.
confirm?
Now it's clear.
Is it echoing? Sorry, I can't hear. Like someone has unmuted. So is it echoing? Okay, it's clear, right? Okay, fine. Yeah. The thing is, so dendrites takes up the inputs, and the cell body which is present over here, it process that input, and synaptic terminals what they'll do, So once the processing of inputs is completed, then the synaptic terminals will result a output, right? So input is coming up here and the input is processing, and this processing creates a output which is delivered by the synaptic terminals in our human brain. So if there is someone who is good at biology, so you can correlate it with the actual biological neuron, right? So this takes up the output. This is the basic functioning of a neuron or a nerve cells inside the human brain. Correct? In the same manner, we have artificially created the same nerve cells here, which is a artificial neural nerve cell, right? So this is called as natural neural network or natural nerve cell, but this can be called as artificial neural network or artificial nerve cell, right? Yeah. So this was created artificially by the scientists whom I have mentioned earlier, and this is called as artificial neural network. Okay. So when I call this as a natural neural network, we must call this as a artificial neural network. So discussing about or discussing in detail about the artificial neural networks is nothing but your deep learning. Okay. Hope you got the idea of what deep learning is all about, right? So now let us understand this definition. Okay, so deep learning is a subset of machine learning and artificial intelligence, which you already know, that uses multi-layered neural networks. So this is a neural network, and this is multi-layered actually. Okay, so that uses multi-layered neural network and understand complex patterns in large data sets, which you are going to know in the coming slides. Okay, so this is inspired by the structure of human brain that you already know. So this gives you a small context over here. Just as the brain uses neurons and synapses to transmit signals, which we have discussed, artificial neural networks use nodes and weights to process information and learn patterns. Okay, so you just get a basic idea. These are called as nodes. Okay, and these dots which are traveling from this node to this particular node, it is called as a weight. Okay, so these green dotted ones which are moving from this big green node to the other one are nothing but your weights. Okay, we'll discuss in detail in the next classes. If you do not understand about the nodes, you need not to worry at this point of time. All right. Yeah. So this is what we were talking about. So these are the inputs, okay, and this is the one, your cell body, which is processing the input, and this is the output, okay, which is being delivered by your synaptic terminals. Okay, so the same representation which we have here, I simplified it and kept this way. Okay, this is nothing but your artificial neural network. Okay, and the small green ones which were traveling from the input to the other node is nothing but your weight, as I said earlier, right? So this is a simple representation, and if you can understand this, you already know the concept of deep learning. Okay, so you already learned the essence of deep learning at this point, so you must be happy of that. Yeah, this is a single neural network. Okay, and if I want to make it huge or multi-layered, it looks like this, right? So if I call the previous one as a single neural network, so we should call this as a multi neural network, right? So this multi is replaced by the word called as deep, and this neural network is called as a deep neural network. So studying deeply on deep neural network is nothing but your deep learning. Again, a new definition has come up, but the meaning hasn't changed, right? Yeah. Now you can ask me, what are the applications of deep learning, right? So you are saying, so you can ask this. You are saying deep learning is a very small concept and it deals about a neural network, which is nothing but a combination of three layers. One is the input layer, and all these are hidden layer, and this is the output layer. So based on these three layers, is the deep learning is completely dependent? So if it is dependent, what are the applications we have in the real world, right? You should get this out. So deep learning is all about three layers. We have many applications. Okay, firstly, the image recognition. Okay, so for example, image recognition means, I was telling in the first demo, right? So for example, you are using your face recognition phones. So based on your face mode, your phone is able to unlock. So how it is recognizing your face? That is based on your deep learning, okay, which we called as image recognition. So that application is not limited to the phones itself. For example, if you are a part of a healthcare domain, yesterday someone has asked about this. So if you are part of that, so image classification or studies on X-rays, MRIs, CT scans, etc., are all dependent on this image recognition itself. And this particular topic is called as computer vision, which is part of your generative AI, but it comes in your deep learning concept itself. Okay, and the next one is natural language processing. Natural language processing is nothing but you're already using the chatbots like chat gpt, gemini, claudia, or whatever. So all those chatbots have been developed by the principles of natural language processing. Okay, yeah, we, this is a separate field, I was saying, right, you can apply to NLP specialist role. So the concept all starts with this natural language processing itself, and it advances to RNN, LSTM, VAE, and transformers, and then large language models. So large language models comes under this natural language processing concept. Okay, however, this natural language processing is again dependent on deep learning, right? So if you understand completely about deep learning, you can understand the natural language processing and thereby large language models. Okay, and then speech recognition. So you already know we have been using Cortana, Alexa for Amazon, or Siri in iPhones, right? So all these are part of your deep learning applications, right? And then self-driving cars, which I said earlier, and predictive analytics like forecasting, etc., are all part of your deep learning. So deep learning is the first step of generative AI, or NLP, or I mean natural language processing, or computer vision, or even the large language models that we are going to discuss in the coming few days. All right? Yeah. Yes. So I told you about the weights. Okay, I told you about input, I told you about weight, etc., etc., right? So I'll stop the session with this topic itself. Okay, So you will get good understanding of what the weight is and what the inputs are. All right. So for example, let's say you're crossing the road. Okay, so this is a person, let's say this is yourself, and you are crossing the road. Okay, and what are the things comes into your mind? Just tell me. So when we want to cross the road, you should know whether any vehicle is approaching towards you. Okay, or that is the first thing. And also, are you hearing any kind of car honking sounds or horn sounds, right? So these are the two things come into your mind. So these are so when we want to cross the road, these are the two input values you are going to consider. Am I right or wrong? So these are nothing but your inputs. So the input is the road clear, and can you hear any cars coming towards you or nearby? Okay, so these are the two important inputs. And then what are the weights we were talking about? So the weights we were saying, right, the green dots which are traveling from the input to the hidden layer. So those are nothing but your weights. What are these weights? So weights are nothing but how much importance you have to give to each of the input. Okay, so for example, w1 is a input. All right, so w1 is a weight which is corresponding to the input x1. Okay, so is the road clear? For example, you are crossing the roads, right? So to what input are you going to give more importance? So you'll check whether any car is coming towards you, right? So you will be giving 100% importance to it. Am I right or wrong? So we will be giving importance of this visual input as 100%. And importance of auditory input. So can you hear any cars? So for example, some car is not coming towards you, but on the other track the car honking sound was heard. Okay, so you will be giving less importance to this, right? So you will be giving only 70% or 60% of it. Okay, so importance of auditory input here at this point is 70%, and importance of visual input here is 100%. So if you understood the inputs and weights, 50% of the deep learning syllabus is completed. All right, so if you understand this particular concept, you have already got 50% of deep learning. Okay, see, I'm not exaggerating actually. Okay, but this is a general example how our human brain work, right? This particular example is ourself crossing the road each and every day, right? Okay, but this is applicable to almost all of the applications. Okay, so that's what a deep learning is all about. And we have discussed about inputs and weights. Okay, so this is a typical neural network. Okay, so these are the inputs and these are the weights associated with each of the input. And this is sigma by f is nothing but what is the processing that is happening, right? You'll be thinking, right? So the weight is 100%, and which means the car is not approaching me, so I can cross the road, right? So that processing is nothing but that sigma by f. And y is whether to cross the road or not. Okay, at this point of time, hope you understood. And what is this b? This b is nothing but your bias. Okay, and if it is night time, you can't see the road, right? So just for your carefulness, you are adding some more value to this output actually. Okay, or for example, you are keeping earphones, and you are not able to hear any kind of car sounds. So just for your extra carefulness, you are keeping this or you are adding this additional value to this. So if you have understood this particular concept, right, this is what your neural network is all about. Okay, and this is a single neural network, but we'll have multi neural network, which is called as your deep neural network. And discussing about this deep neural network is nothing but your deep learning. Okay, so do you have any questions here? So I would like to ask or pick someone from the team, and I would like to ask this doubt question, right? So someone please ask a question. So if you have any doubt or gaps in this particular basic understanding of the principle, so you can ask me at this point of time. Okay, so nobody's uh, I think nobody has any doubts. That's the reason you are not raising any doubts, right? So let me stop at this point. So if you have understood this, we are going to apply this same kind of principles using the TensorFlow and PyTorch, which are nothing but your deep learning libraries, Python frameworks or libraries. So you need not to draw all these diagrams. Okay, all these things will be happening inside that particular framework itself. We are going to discuss this entire concept in a very detailed way. I'll be using notepad to explain all this, and even we are going to discuss the math problem. Okay, math problem, our in our graduation or in btech, we had forward propagation or back propagation, forward propagation, right? So all these topics will be coming up here, and I'll be explaining a math problem. So if we explain that math problem, you will understand most of it. Okay, so usually people won't follow that, explaining a math problem in a software training program, but we'll have to explain that for a detailed overview of what is happening. I'm going to stop at this point, and I would like to show you. Yesterday we talked about lang chain, RAG, and all, right? So let us see how how can we build up a chatbot simply using the lang chain. Okay, so this is the code, and I don't want to show it because it has my OpenAI API key. Okay, so which will have to it is a secret key, which so once you practice in your real time, you will be understanding the importance of it. Okay, so for now let me show you how to develop a chatbot using the lang chain. Okay, so this is a very simple code. This is just a 15 lines of code. Okay, you need not to worry a lot about it. This is just a 15 lines of code. Okay, now let me show you how to build a chatbot. It won't take much time, just 2 minutes of your time, just understanding the importance of these frameworks or importing these libraries, etc. Okay, for example, let me show you this chatbot. Yeah, I'm running it. I have the code ready. So this is a chatbot. Okay, so yeah, let me ask it a question, basic question. um Can someone give any question related to your, not about this artificial intelligence or machine learning? You can ask any general question to it. Can someone raise any point? You can type in the chat box, right? Oh, sorry, I did not see the chat. Sindura has already, given answer for this deep learning. Yeah, that's nice, nice, and that's a correct answer. Okay, and what Python libraries do you cover? That we'll be covering. Okay, for now, let me ask it a simple question. What are the top 10 tourist places in India? Okay, let us ask this question. Yeah, this is the one. What are the top 10? Yeah, it has given. See the top 10. Okay, likewise, you can ask any kind of questions, right? What are the important um, traffic signs available? Yeah, it has given that particular question as well. So this is a chatbot which I developed using the API key of OpenAI. So it is nothing but your GPT model. Okay, So yeah, doing that you can easily create a chatbot, right? And in the same way, let me run one RAG application. Okay, so I'm running a RAG application. Yeah, it is opening up. So what is this RAG? RAG is nothing but the meaning is retrieval augmented generation. You can we will have a deep understanding on this after we cover the LangChain concept and the architecture of LangChain. Okay. For now, I have a document here. Okay, so this is a document about my our course. Okay, GenAI. So this the name of the course is Advanced Machine Learning and Generative AI, and I kept the demo session timings. So the first demo happened on April 23 at 9 p.m. and second is 24. Okay, and we gave some set of information to it. So this is nothing but your document, right? And we are going to ask a question from that document. Firstly, who are the trainers of this course? So I have asked it a question, who are the trainers of this course? So it must be able to give a correct answer. Let's see. So it is giving a generic name. Okay. So what are the names of trainers of this course? Okay, let's see. It can understand this particular question. Yeah. So the trainers for this course, Advanced Machine Learning and Generative AI Job Oriented Program, are Vasant Banu and Naveen Maurya, right? It has given the answer correct. So the second demo session is scheduled on April 24, 2025 at 9 p.m. Whatever we have given here, it is going to give that answer. Okay. And what? So let's ask one more question. I just want to give you who are the target audience for this course. So the target audience for this course is anyone aspiring to break into machine learning and generative AI, whether a fresh graduate or someone switching careers. No professor are required as the course teaches everything from scratch. See, but whatever I have given you, given here, is not entirely same, right? We teach everything from scratch, right? However, the thing over here is completely different, as the course teaches everything from scratch. So this is how the RAG application is going to work, and I'm going to stop at this point. Okay, I think it's a high time, right? Yeah. Hope. Do you have any questions in the audience? Someone has asked a question. What Python libraries are we going to cover in this course? Banu, could you please pitch in and answer to that particular question? Okay, maybe I think
Yeah,
he's having
I can
some
hear you.
audio
Yes.
problem.
No, 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 no. I can hear you. Can you hear me?
Uh, yeah, yes, yes.
Okay. So as part of Python libraries, so we cover mostly from pandas. Basically, lots of libraries are available, but we will start with the pandas. It's a array data manipulation Python library, and next comes the NumPy. NumPy is also one of the array manipulation technique. Let's say, for example, data is present in a table, and you wanted to modify anything in any CSV format labs, you will use the NumPy libraries. Also, we have other libraries for the data visualization. So for the data visualization, we use Matplotlib for the representation. Let me just share it at the moment. No, it's not that important, but I can tell you orally. There is also other libraries called scikit-learn. where you will try to import the machine learning, different machine learning models, and so that you will be able to apply those models. Uh, okay, so scikit-learning is one more library you will use. There are lots of plenty of libraries we are going to use it as part of our learning curriculum. So, but don't worry at the moment. It will be much deeper than that what you think, but in a simple manner. Okay. So so far I think I explained you four libraries like pandas, numpy, scikit-learn, and matplotlib. Okay, but these are not limited. Once you get into the course, you will learn more and more libraries. Okay, hope I answered your question.
Okay. So you have covered what Python libraries we are going to cover, right? And the next question is, what is the difference between RAG GPT and Chat GPT? Correct me if I am wrong. LLM is Chat GPT or not? See, basically, all these LLMs when they have come up, right? For example, OpenAI, you take that particular, LLM provider. Okay, so OpenAI has started with GPTs, right? So GPT 1, GPT 2, and GPT 3.5, right? These are the three, the first versions of OpenAI chat GPTs. So that particular information, whatever it was having earlier on those days, was nothing but the data which was trained to it. Okay, trained data, if it is able to give you answers properly, it is nothing but your GPT, or a small base foundation model GPT, or this can be called as LLM as well, right? And next question is, what is RAG in it and what are RAG GPTs, right? RAG is nothing but, apart from training your data, training the data to the model, if you are going to give additional information to it by any external sources like databases, or data warehouses, or simply documents, etc. So if you are going to give additional data to it to give you a specific answer from that particular document itself, then it is called as RAG. Okay, it is retrieving the data from these particular data sets. That is why we are calling them as RAG. Okay, so an LLM is something which can have a RAG in it or not. Okay, it's completely dependent, it's completely independent. Okay, so it's basically how you want the data to be, or how the GPT wants the data to come up to the user. Okay, so that is nothing but your RAG. And you also asked, if I'm wrong, LLM is chat GPT, right? Yes, yes, absolutely. LLM is nothing but your large language model. Okay, so when we say large, okay, so it was trained with huge amounts of data. That is one thing. Okay, and it was trained in a specific language like English. Basically LLMs or any computers can't understand English language, right? So they basically should convert English language or any other language into numbers, right? So this particular model is able to do that. Okay, so that is the reason we are calling them as large language models. I'm just keeping you basic understanding of what this is. But large means it is, it has been trained with a huge amounts of data, and huge amounts of infrastructure is required, because we'll have a deep neural networks involved in it. So huge computation costs and huge amounts of weights and biases are getting updated each and every time when the program is running behind. Okay, so that is what a large language model will be doing. So that is a advanced understanding of this particular definition. But yes, your question, chat gpt is LLM, correct? And rag gpt is someone, it will have both LLM and the data is fed in terms of databases, data warehouses, or documents, or whatever. So additional information that we want to fetch is nothing but your rag. Yeah, hope I answered your question, Sindhura. Okay, and we don't know the available data. How do you write the prompt to get the accurate results from the existing data? See, the basic RAG application, whatever I have shown you, this is about only the 20 lines of information, right? And the model that I have used is not even the basic foundation model. That's the reason we are not able to fetch if we don't give the prompt correctly. Okay, for this type of free and not even foundation models, we cannot expect it to give the proper results when we don't give a proper prompt. Okay, so in real time, this rag information will be millions of data that we are going to feed. Okay, so in that particular time, and the LLM which is associated with it will be a high end model. Okay, so when you have high end model LLM and you fed it with huge amounts of data using the RAG, then it becomes a powerful chatbot, which is again called as a large language model. Okay, so here in these cases, even if you don't give a proper prompt, it can understand and deliver the answers very effectively. One of the example is ChatGPT. Okay, so yeah, hope I answered your question. Yeah, do we have any other questions? Some messages, Stat, what would be the sequence of this? You said that you'll cover basics of Python, mathematics, and stats. What would be the sequence of this course? Would it be the same as in the brochure? Yes, correct. Yes. We'll be starting the course with Python, and then we'll moving towards the mathematics, statistics, machine learning, and then the generative AI course. Okay. Hope you, yes, we are going to maintain the brochure, the same content sequence. Okay, yeah, hope I answered all the questions. So if you have any further questions, you can just ping in our group, WhatsApp group itself. Will be available to reply back. It may take some time, but we'll be surely reply back to your question. Yeah, thank you so much for your time. So I would like to mention one more point. Whatever the course we are covering here, right? So this particular course, if you search anywhere outside in the internet, you will see it will be more than 1 lakh, right? It will be, more than 1.5 lakh. I would say. I request all of you who have attended the course to just Google it. What is the price of this content? Okay, you will get a very good understanding, right? And we are going to cover everything in from the starting. Okay, from the basic, from the zero level, I would say. Okay, so hope it answers all your questions, and thank you so much. All right, yeah, Banu, if you want to add something, you could, or we'll wind up the session. Yeah, thank you so much. Have a great evening, everyone. Yeah, bye.